Okay, so I'm going to talk about this question from the skills section. In the first part of the question, it asks you to prove that an equation can be written like this. 3 sine x minus 1 all squared is equal to 2. And the second part of the question asks us to use this to solve it. So normally when we see questions with trig and quadratics, it's normally because we're able to factorise it and get 2 solutions out of it. But this one, if you try to expand and then make it equal to 0 and factorise it, it's going to be a little bit more complicated. So the fact that we've been asked to do this in the first part of the question, and this one said, hence solve, means this is going to be useful to us. So realistically, what we've got here is a situation that we can kind of undo all the operations that happen into that sign by just square rooting it to start with. And I think that what a lot of people may have forgotten is that obviously when we square root it, we've got plus or minus. So that's where like our 2 situations are going to stem off from. Then all we need to do is add 1 and divide by 3. So we get either sine x is root 2 add 1 over 3, or sine x is going to be equal to minus root 2 add 1 over 3. So we're going to want to inverse sine both of those and get our 2 original solutions here. So let me just do that one. So sine inverse of root 2 add 1 over 3 is, I'm in radians, so I want to put that out first. Worth checking, because our domain of our values is between 0 and 360 degrees. That means I know it needs to be in radians. So I'm going to try again, putting it in degrees. So I get sine inverse root 2 plus 1 over 3. And it's a really good idea here to make sure that you're not actually working out what that value is and then inverse signing it, because you're going to then be rounding twice. The fact that I'm keeping it in terms of those surds and those fractions means that my answer is only going to have to be rounded the once. So what I'm going to do is round it to 2 decimal places to start with at this point. If I was to then go and do further stuff with these, so say for example you were solving one with stuff inside the sine function, I may do a few more and then only round it at the very, very last minute once I've undone all the operations. But I'm going to leave it like this for the time being, and not forgetting that I'm going to state what I have rounded it to for SF. Then do the same for the negative root 2, and I get minus 7.94. I'll do it to the same degree of accuracy and do that for SF. Okay? So we've got 2 solutions. It's then just finding where they are between 0 and 360. So always drawing a graph. I saw lots of you in my class specifically that weren't drawing graphs for these. So drawing it between 0 and 360 and figuring out where those points are going to be. So 58.58 is going to be here. So I can clearly see that I'm going to get another solution at 180 minus that. So another solution for this will be 180 minus 58.58, which is 121.42. Again, that's been rounded. So that's that one. This one, the first solution that we've got isn't actually even 1 at all. So I'm just going to use a pen to draw this one on my sine graph as well. So this one is actually at minus 7.946, not even a solution itself. So this one actually doesn't even count, but it will help me find the other 2 that are between 0 and 360, which will be these 2. So looking at that gap of being 7.946, I'm going to add that on to 180, and over here take it away from 360, using that symmetry of the sine curve there. So I've got 180 plus 7.946. That gives me 1 187.946, and same again, 360 take away 7.946. Okay. The one thing that I'm now going to do is just put all of my answers nice and easily together, all to the same degree of accuracy. So I'm going to do these all to one decimal place. I don't think it said anything in the question. Let's just double check. Oh, it says in the question, give all your answers to 2 decimal places. So I'm just going to make sure that I do that now. So X is in order of size 58.58 degrees, 121.42 degrees, 187.95 degrees, and 352.05 degrees. So making that nice and clear what our final ones were. Because it told us in the question what degree of accuracy it wanted at, if I didn't do that, I'd have lost some marks, so watch out for that one. And hopefully that explains how to solve trig equations of a format that isn't a quadratic that can be factorised. Okay, lovely.